Good evening, friends. Today I'm going to explain the chapter Redox reaction of grade 11th chemistry, and that chapter is the unit number 8. So we'll discuss through the maximum of the topic we will try to cover in this 1 hour lecture. So let us see that what are the topic and what is the meaning of the chapters. So the chapter is redox reaction. Redox reaction. So first of all, let us understand that is reaction, and then we will try to understand the redox. What is meaning of? So reaction means that is the there is the change is there, chemical change and physical change there. So whatever the chemical change are there, chemical change that study in the form of the chemical reactions. Okay, and what are the chemical change? That is in chemical change we know that is new product form. Okay, new product form, new products form. In physical change, in physical change we are not studying that. Physical change, what we study, that in physical change only the transformation physical state change, like that melting of ice. Okay, so melting of ice, if there ice is there, and that again this is ice is was nothing but water, and again it will be the water. Okay, so that is the what is happening, solid to liquid, only phase change. But here suppose what is there, carbon is there, it is burning with the oxygen, here is carbon dioxide form. Okay, new substance is getting formed, and that is irreversible. So it will be the chemical change, and that chemical change is studied under the chemical reactions. Okay, now there are so many types of chemical reactions are there, in which we are going to study, that is redox reaction. Okay, so in the redox you see there are two words are there. First one is red and second one is ox. Up now for the ox only term you take, that is ox means oxidation. Okay, and red means this term is meaning of the reduction. Okay, now when you are going to understand oxidation, oxidation means what is, increase in oxidation number, you can say. Okay, oxidation, there are the two different concepts are there. Old concept is there, new concepts are there. And old concept is there for the that is also known as classical concept. Okay, so combine both the two. Okay, reduction and oxidation, because these two are the same. So, what you are finding redox reaction definition, the reduction and oxidation reaction both are taking place simultaneously. That reaction is known as what? Redox reaction. So here we are defining the reaction in which, the reaction in which, the reaction in which both both oxidation and reduction reaction and reaction takes place simultaneously. So if oxidation and reduction reaction both are taking place simultaneously, so that type of reaction is what is known as what? Redox reaction. Okay, now that you understand, that is the both reaction is taking place, oxidation and reduction reaction, that is known as redox reaction. Now we are going for the, firstly let us understand separately, then we will understand together. So first one is the classical concept. Okay, classical concept. Classical concept is also known as old concept. Okay, old concept. So one by one, firstly you try to understand oxidation reaction. What is meaning of oxidation reaction? Okay, so oxidation reaction, the old concept is saying that is addition of, okay, addition of oxygen. Okay, first one is there for addition of oxygen. Second one is there addition of electronegative 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 elements. And third one is there, that is removal of hydrogen. Removal of hydrogen. So these things are taking place. These three things are happening. So according to classical concept, this reaction will be the oxidation reaction. Now you see that it's carbon plus oxygen. That is addition is taking place. This is what is that addition is there. Addition of oxygen. That is this reaction is oxidation reaction. Similarly, you can say that is Mg is there plus O2. Okay, 2 Mg you take. So what we is forming that is MgO. Okay, 2 MgO. So here addition of oxygen is there. That is again what is this is the example of oxidation reaction. And secondly, if you try to understand that is suppose zinc metal is there and sulfur is getting at that is ZnS. This is electronegative atom. So again, this will be coming what oxidation reaction. And if suppose another example, if Mg is there plus you are adding Cl2, so it is giving MgCl2. Okay, so this is again electronegative atom. Okay, these are the in the term defining in the terms of addition of oxygen, but these are defining in the terms of electronegative atom. This is the electronegative atom. So either the you are adding the oxygen atom or you are adding the electronegative atom, these both the terms are what the example of the oxidation reaction. Okay, now if you see the you know example of that is the removal of hydrogen. Suppose we are having that is if you are treating this C2H6 is there. Okay, and if you are doing some chemical change and it is forming C2H4 and plus here is H2, so removal of hydrogen is there. So this is also an example of the oxidation reaction. So whether you are adding the electronegative atom or oxygen atom, that will become the oxidation means addition of oxygen. And secondly, that is if you are removing the hydrogen atom, electropositive elements, that is also the oxidation. Okay, now let us go for the classical concept and let us study what is the meaning of the reduction reaction. Okay, so let us understand that is reduction. Okay, reduction. So what is meaning of reduction? Let us understand. So that is old concept that for that also we are writing. First one reduction means removal of hydrogen. First one a removal of oxygen. Okay, this is what removal of oxygen is what the example of the reduction reaction. And second is removal of electronegative atom. Removal of electronegative atom. Electronegative atom. And third one is there, that is addition of hydrogen. So addition of hydrogen. So according to old concept, these 3 points are there for the for the reduction reaction. Okay, now how to understand this? That is they with the help of example. So to understand with the help of example, see we are having the Cl2 and you are treating with the H2, so it is giving 2 HCl. So this is what it is happening here is the addition of hydrogen taking place. So it is also a example of the it is the example of the redox reaction. It is the example of redox reaction. And if you go for the some more example, suppose we are having CuO plus H2 is there. Okay, CuO plus H2 is there, and this reaction is also a types of redox reaction in which what is happening, this oxygen is getting removed. So removal of oxygen will be there. So what is there? Cu plus it is giving H2O. So removal of oxygen is taking place. So it is also a example of redox reaction. Okay. And if suppose I am having ZNO, it is reacting with carbon. Okay. So it is giving that is Zn plus Co. Again, what is happening? There is the removal of oxygen is taking place. So it is also a example of redox reaction. So there are the several examples are there of the redox reaction that we can understand with the help of examples also in terms of the classical concept. And classical concept is nothing. No, classical concept is nothing only that is they are saying that is addition of oxygen, that is the oxidation, and removal of oxygen, that is reductions. Okay. Now we can go with the modern concept. Okay, modern concept that is also known as electronic concept. Okay, so let us understand that is redox reaction with the help of with the help of okay, modern concept modern concept in bracket electronic concept. Now, what we have to understand in the electronic concept, this is the universal acceptance. This is universal acceptance. It means universal acceptance means that is the now this is being followed in the today's time. So electronic concept is very simple. Definition is there, that is for oxidation. What can we write for oxidation? Simple, only one line definition is removal of electron. Removal of electron. Removal of electron is known as what? Oxidation reaction. Now, how can you understand this is removal of electron is the oxidation? Suppose we are having the Na atom and it is forming, that is Na plus electron. So here is the zero charge is there. Here is plus one charge is there. So this is the example of oxidation reaction. Now, if you see another example, suppose I am having Mg, and if you are doing the oxidation, what oxidation it will give? That is a removal of Mg2 plus 2 electron. So here is what is change is there, 2 positive, here 0 to 2 positive. So this is also an example of oxidation reaction. Suppose we are having Sn2 plus and it is changing into Sn4 plus, and here is plus 2 electron is there. So this is what is, this is again there is increase 2 to 4. So this is again example of what is, this is the example of oxidation reaction. So removal of electron is the example of oxidation reaction. Suppose we are having, that is Fe2 plus is there, and here is it is converting into Fe3 plus 1 electron. So here is again increase in oxidation number 2 to 3. So this is what is again the what is case of, this is also a case of oxidation reaction. Okay, so I hope this is getting, you people are understanding this. Now let us understand that is the modern concept of the reduction reaction. Okay, what is meaning of reduction reaction? That is reverse of oxidation reaction is oxidation. Okay, so this is if you are going to understand reduction. Okay, what is meaning of reduction? First let us try to understand the meaning of reduction. Reduction means reduce in what? Reduce in oxidation number. Okay, reduce in oxidation number, that is reduce in oxidation number. This is meaning of the terms. Okay, and what is exact definition? Addition of electron. Addition of electron is known as oxidation number. Is known as oxidation number. Okay, addition of electron is known as oxidation number. Now let us go with the examples. Okay, there's a similar example we are going to do, that is suppose I am having Fe3 plus cyan is there and 1 electron you are adding and it is converting it to Fe2 plus. So what is happening? Reduction in oxidation number 3 to 2. So 3 to 2 is the example of what? This is the reduction reaction. Now next one is there, suppose Sn4 plus is there. Okay, and if you are adding, that is 2 electron here, so it is converting into what? Sn2 plus. Sn2 plus. Now see, here is reduction is oxidation number is there. So this is what reduction reaction is there. Okay. So if suppose Sb5 is there, Sb5 plus is there, and in that if you are Sb5, if you are adding the electron, suppose 2 electron you added, so it is Sb3 plus is giving. So what is happening here? Plus 5 to plus 3, that is reduction is there. So this is also an example of reduction reaction. Okay, now let us understand that is the next term, the redox reaction. Okay, we are going to study the combined way, that is the redox reaction. And redox reaction, what we are saying, that is a redox reaction. In redox reaction, both oxidation and reduction reaction are taking place together. Okay, so how to understand this redox reaction? Let us understand. Okay, now, okay, so next one is we are going to understand the redox reaction. So a redox reaction. So definition I already told, that is reduction plus oxidation, and this is reduction plus oxidation. This is happening what? This is happening together. Okay, and this is, since this is happening together, so this is also an example of redox reaction. Okay, now let us go with the help of, let us study with the help of examples, and then this concept can be the clear. So suppose I am having the, compound. I am having one example I am taking, and what compound I am taking, that is what H2O2 is there. Okay, H2O2, and it is getting decomposed, and it is giving H2O plus O2. Okay, H2O plus O2. Now see what is happening here. In this one, from here, there is a loss of, here is a few few of the oxygen molecule is getting removed. Okay, so what we can do with the help of oxidation number, I am trying to explain with the help of, if you want to calculate the oxidation number of this element H2O2. So H2O2, suppose I am considering this 2x, because two oxygen, so 2x, and hydrogen is universal plus 1. Okay, except metal halide. So hydride. So here is 2 hydrogen, so multiply by 2, equal to, no charge is 0. So 2x is equal to minus 2. So x is equal to minus 2 by what will happen? 2. So x is equal to minus 1. So here what is there? Minus 1. Now we see this one is the no, neutral molecule, so oxygen is 0. And what is H2O2? If you go H2O2, you consider this is X, because oxygen is 1. So X plus, how many hydrogen are there? 2 hydrogen, and 1 hydrogen is having 2 charge. Total charge is 0. So plus 2 plus X is equal to 0. So X is equal to minus 2. So here is what is happening? Minus 2. Now see here oxygen. Oxygen here is changing minus 1 to minus 2, more negative. So this is what is reduction. And minus 1 to 0, this is the increase. So this is the oxidation. So what is happening in this reaction? Both things are, oxidation number is increasing and oxidation number is decreasing. Both the things are happening. That is why this is the example of what? This is the example of redox reaction. Okay, now let us understand with the other, with the help of other example also, the redox reaction with the other example. And what other example? Suppose I am having the zinc, and then we are having the CuSO4. This is what is happening, ZnSO4 plus Cu. Okay. Now, if you want to, SO4 is having two negative charge. So in the Cu neutral state, this is zero oxidation state, simple. So if you want to calculate for the CuSO4, so here we are considering this X, and here in my bracket SO4, how much charge is there? Minus 2 equal to 0. So X is equal to plus 2. So here is what there? Plus 2. Similarly, if you go ZnSO4, so Zn will become X, we are calculating for that, and here SO4 minus 2 charge is there, so equal to 0. So X is equal to, this will go that side, that is also plus 2. So here is plus 2. Zinc to zinc we are watching. So let us see what is happening. Zinc to here, what is there? 0 to plus 2. So this is what is, this is the oxidation. And plus 2 to 0, this is reduction. So both the reaction are taking place together. So this is again an example of the redox reaction. So these many things we studied, that there are a changing, in the oxidation number, that is the reduction in oxidation number, and increase in oxidation and decrease in oxidation number both are taking place. That is why this is the types of redox reaction. Now what we are going to do, we are going to study what are the types of redox reaction, and then we'll finalize that the detailed conclusion about the redox reaction. So redox reactions are generally, 4 5 types are there for redox reaction. So let us understand one by one with the help of example. So here what we are going to do, we are going to study the types of redox reaction. Types of redox reaction. Types of redox reaction. Okay. So types of redox reaction, there are so many types of redox reactions are there. Firstly, let us try the right name of the types. First one is combination. Simplest type is combination reaction. Combination. Combination reaction. And second one is decomposition reaction. Decomposition reaction. Okay, this is the decomposition reaction. So decomposition reaction, and third one is displacement reaction. Displacement reaction. Displacement reaction. And fourth one is disproportionation reaction. So there are 4 types of reaction we are going to discuss here in these chapters. Okay, and these 4 type of reaction are, that is the example of the redox reaction. Let us try to understand this. All the first one we are going to study, that is the combination reaction. In combination reaction, what is happening? Two elements combine to form the one element. That is the combination reaction. So two elements are combining and forming only one element. That is what is known as combination reaction. So with only we are going here, the simple is what is there, a plus b. If they are saying this is the a plus b, and they are saying this is c, so this is the example of nothing but this is the example of combination reaction. Now what we are going to do, we are going to study with the help of example. Suppose I am having the carbon and it is the oxygen. So it is the combining to forming the carbon dioxide. Here oxidation number 0, here oxidation number 0, here oxidation number is +4, here oxidation number is +4, and here is -2. How +4, how -2? CO2 is there. This if you want to calculate x, and oxygen is two atoms are there, and each is having that is 2 negative charge equal to 0, so x is equal to +4. Okay, now for the reverse order, if you are so for a carbon +4, if you are calculating this, 2x is there and here is +4 equal to 0. So 2x is equal to what will happen here, -4. So x is equal to -4 by 2. So what is have coming, -2 is coming. So -2. So here what is carbon to here, 0 to +4, this is the oxidation, and 0 to -4, this is the reduction. This is the reduction. So this is the example of the redox reaction. And if suppose if you are going for the, suppose you are going the 2 mg atoms combined with O2, and this is giving the 2 mgo, 2 mgo. So here is 0, here is 0, here is +2, here is -2. So 0 to +2, this is oxidation, this is oxidation, and here is, and 0 to -2, this is the reduction. So this is also the example of redox reaction. Okay, now we can learn this with the so many other example. Suppose I am having Fe, and if we combine with the s, so it is giving FES. So here is 0 0, here is what, +2, and here is -2. So 0 to +2, this is what oxidation, and 0 to -2, This is what, this is the reduction. So this is the all are the combination reaction in which one is two is combining to giving one, and they are change in the no decrease and increase in oxidation reaction is oxidation state is taking place. So this is the again example of the redox reaction. Now let us move with the other type of example, and that example we are going for the decomposition reaction. Okay, so we will study the decomposition reaction. Means the one element, one compound is converting into, in decomposition event, one compound is getting broken down into two or more than two. Okay, so one is already, we have, suppose we are taking the water, two water molecule you are taking, and what is happening if you are heating this, so it will give 2H2 plus O2, and oxidation number here is 0. Here is what is happening, plus 1 minus 2. So what is happening here, plus 1 to 0, this is the reduction. And what is minus 2 to 0, this is oxidation. So here water decompose into hydrogen and oxygen, and this become the, you know, redox reaction. If suppose I am having NaH, and what is it is giving, if you are taking two molecule, it will give, that is 2Na plus it will give the H2. Now you see here oxidation state both are 2. Here is plus 1 minus 1. So what is happening? Plus 1 to 0. This is the reduction. And minus 1 to 0. This is the oxidation. So again this is the decomposition of the, you know, metal hydride, and where we are watching that a change in oxidation number is taking place. So this is also an example of redox reaction. Now if you see, suppose I am having HgO. Okay, now if you are, you know, this, if you are heating this if you are heating, it will give the Hg metal, and it will give the oxygen also. Two molecule, here is two molecule. So you see what is the change in oxidation number. Here is the 0, here is also 0, free molecule. Here is minus 2 and here is plus 2. So Hg plus 2 to 0, this is the reduction, and minus 2 to 0, this is the oxidation. So decomposition reaction is also a example of, that is the redox reaction. Now next type is, we are going for the displacement reaction, and let us understand how the displacement reactions are example of the redox reaction. So next one is displacement reaction. Displacement reaction. Displacement reaction is also an example of redox reaction, in which what is there, we are having that is xy, and we are treating with the z. So what is z will displace any of these, so it will form, that is zy plus it will form the x. So z is displacing x. Okay, displacing s, displacing x, displacing x. So what is happening, there are two types of displacement reaction are there. First one is what is known as metal displacement reaction. Metal displacement reaction. This is the metal displacement reaction. What is meaning of metal displacement reaction? One metal displaces another metal. So suppose we are having the copper sulfate is there, and if you are treating with the zinc, it will give, that is ZnSO4 plus it will give the copper. So here is 0 plus 2, 0 plus 2. So here zinc 0 to plus 2, this is the oxidation, and plus 2 to 0, this is the reduction. So this is the type of redox reaction. Now if suppose we are having the another example, suppose I am taking NiSO4, and this NiSO4 is treating with the carbon monoxide. Okay, or the you treat with the cobalt, not carbon monoxide, cobalt. So what you are finding, it is giving, that is cobalt sulfate, COSO4, and that is they are giving also the Ni. Now you see the change in oxidation number. Here is 0, here is 0, here is plus 2, here is plus 2. So nickel to nickel, what is plus 2 to 0? This is reduction. And here is CO2 0 to plus 2. This is oxidation. Both are taking place. So it is the, it means it is the example of, okay, metal displacement reaction. Now you see the non-metal displacement reaction. Okay, now it is time to study the non-metal displacement reaction, and let's see what is the non-metal displacement reaction. So in non-metal displacement reaction, that is the non-metal will be getting displaced. Okay, non-metal will be getting displaced. So let us see for the non-metal displacement reaction. So here is non-metal displacement reaction. Displacement reaction. Okay, non-metal displacement reaction. So first of all, we here in this case, what is non-metal will be getting displacement by metal. So suppose simple example we are explaining here. I am treating with the sodium and water. Okay, H2O, and that both we are taking two molecules, so it is giving that is base 2NaOH plus it will give that is hydrogen gas will be released. So here is oxidation number is 0, here is oxidation number is 2, here is oxidation number plus 1. Okay, so here you see, here is what is Na2 plus, this is what is happening oxidation. This is what is Na2 plus is oxidation. Now you see for the another element, for we can go for the hydrogen. So if you are going for the hydrogen, here is plus 1 is there, and plus 1 to 0, this is what reduction. So both the things are taking place in this displacement. Metal displaces the hydrogen, non-metal. So this become the non-metal displacement reaction. Similarly, you can give the so many examples are there. You can give Mg plus you are treating with the H2O. Okay, so 2 moles of water you take. So it is what the MgOH whole twice. MgOH whole twice plus it is giving H2. Okay, so this is also a type of what is the example of the displacement reaction in which metal magnesium displaces the hydrogen. And similarly you can go, there are several examples. Zinc metal is there, and if you are treating with the HCl2 molecule, let's say, so it will give that is ZnCl2, and then what it will give hydrogen. So what you are finding here is zinc metal displaces the hydrogen. Okay, so this will become the also the redox reaction. And suppose if we are having Zn plus you are treating with the H2SO4, so it is giving what is ZnSO4 plus what it will give H2. This is also a type of displacement reaction. And if you are taking that is Fe and plus it is giving F2HCl, so what is that is FeCl2 plus H2. So it is also an example of the displacement reaction, non-metal displacement reaction. Now, the next very important types of redox reaction, and that redox reaction is known as what? Disproportionation reaction. Okay, so let us understand what is meaning of disproportionation reaction. If the same element, if the same element is oxidized and reduced, if the same element is oxidized and reduced, then this concept is known as disproportionation reaction. So this is the last type of the redox reaction. So this is the let us go for this disproportionation reaction. Disproportionation disproportionation reaction. What is same elements oxidized and reduced, oxidized and reduced. And if same elements are oxidized and reduced, this comes under the disproportionation reaction. Now one example I am taking here. Okay, H2O2, when it is the undergo disproportionation reaction, it will give the H2O and O2. You take the two molecules, so here it will also become the two. Now this is the example of disproportionation reaction. How this is the example of disproportionation reaction? Here is -1, here is -2 0. So -1 to -2, this is the reduction, and -1 to 0, this is the oxidation. So this is the types of disproportionation reaction. Okay, other example if you want to see, there are several example are there. So you can take many of the example. Suppose phosphorus is there. Okay, white phosphorus is reacting with the base. Okay, so what it is giving, it is giving the phosphine pH 3 plus H2PO2 minus plus H2PO2 minus. So this P2P, okay, so this is what, minus 3, and this is plus 5, and here is 0. 0 to minus 3 is the reduction, but 0 to plus 5, this is the oxidation. Okay, the same element phosphorus is oxidizing and reducing, so this is the disproportionation. Same element oxygen is oxidizing and reducing, so this is also an example of disproportionation reaction. So this is all about the types of redox reaction. In next video we will try to study the finding the oxidation number. Thank you so much for watching, friends.